We'll go over exercise 2, which is another example of the Chi Square Goodness of Fit test. I will show you how to do it on the TI-84 as well as on StatCrunch. So we're looking at 541 Reese's Pieces of candies. We found out there were 273 orange ones, 154 brown ones, and 114 were yellow. So let's say we conduct a goodness of fit to see whether the three colors are equally likely. And without doing any calculations, what do you expect from the p-value? Do you expect it to be small? What do you expect from the chi-square test statistic? And so what's your intuition by looking at it? Well, our previous example, we looked at the number of days, and they were all pretty similar over here, but we can see pretty big differences between the number of orange, brown, and yellow. So certainly we would expect statistically significant results over here, showing that there is a difference between these colors. Whenever we get statistically significant results, we end up with a small p-value. And so that's what we would expect over here. So we expect statistically significant results with a small p-value. Which would cause us to reject the null and therefore show that, yes, we are fairly certain that at least one of these is different. We're going to conduct a formal goodness of fit, but this time we're actually going to follow the Reese's Pieces distribution, which is 50% orange, 25% brown, 25% yellow. And so we will calculate our chi-square test statistic. We are going to find our p-value, make a formal decision. And this time we're not going to do it by hand like we did in the previous example. I will also show you how you could conduct one of these tests with equally likely results, and therefore show you the difference, answering kind of the first part, which we already informally answered, as well as looking at that color distribution given in part 2. So let's set up the hypothesis. Our null hypothesis is that the proportion of orange is 0.5. The proportion of brown is 0.25. And the proportion of the yellow Reese's is also 0.25. Our alternative is at least one proportion is different. So I went to Stat and Edit in order to put in these values into list 1. So we have 273 orange, 154 brown, and 114 yellow. And then in list 2, we're going to put our expected values, which is, again, half of 541. That's 270.5. You can also do that calculation directly within the list. And then 1/4 of 541 is 135.25. So it's okay to have decimal numbers for these expected values, as they are just what we're expecting. So we can see that each of these expected values is at least 5, so we are good to go ahead with our goodness of fit test. We also know that this sample is going to be representative because any bag we buy should be representative of the population. So now we're going to go to Stat and Test. We're going to arrow down to chi-square goodness of fit test, which is option D. Our observed are in list 1, our expected are in list 2. We do have 3 different groups, so our degrees of freedom is 2. So we do have to, unfortunately, enter that. that's not auto-populated. And then we're going to hit calculate. Our chi-square test statistic is 5.961, and our p-value is 0.0508. Our degrees of freedom are 2, and then below that it just tells us the contribution, which is the different parts of our chi-square test. If we did it, by hand, that would be the observed minus the expected squared divided by the expected for each of those entries in our table. So let's go back and put in our test statistic. So that was 5.961. Our p-value is 0.0508. If we're comparing at the 5% significance level, it is greater than that, or also if you used 1% or 2% or something else, we are going to fail to reject the null. So there's not sufficient evidence that one proportion is different. All right, and then real quick, I'm going to show you how to do it on StatCrunch as well. I entered in the values on StatCrunch, so we have in the first column the number of orange, brown, and yellow Reese's Pieces, and then we put the expected count into a separate column. To run chi-square test, you go to Stat, Goodness of Fit, chi-square test. The observed values are in Reese's Pieces. The expected, I put into expected counts. When I compute this, this is going to give me a test statistic of 5.961, as well as a p-value of 0.0508. I did want to show you over here when I choose, because remember that original question was asking us, are they all equally likely? And we said no. Well, if I ran this as a chi-square goodness of fit test with all cells in equal proportion, I could calculate the test statistic and the p-value associated with that. And over here you can see our chi-square test statistic would be 75.863 and a p-value less than 0.0001. This is kind of what we expected when we first ran the test, because that seemed very, very unlikely results. But you can see with those adjusted percentages, it certainly is reasonable. This is pretty close to 270.5, and these two are also not far off from 135.25.